Okay, today we're going to study the energy stored in a magnetic field and also the energy density. So if we have an RL circuit, here is an RL circuit. So we have here E, this is the voltage. We have the resistor, this is R, and then we have the inductor, L. Now, and we write the equation, E minus L di over dt. This is the voltage across the inductor. Minus Ri is equal to 0. So the voltage E, or the battery, okay, the voltage of the battery is equal to L di over dt plus Ri. Now, if we multiply this equation by I on both sides, this becomes IE is equal to Li di over dt plus Ri squared. Look at this. This is a power. This is the voltage times the current is power. So this gotta be a power. Okay? So we can write the power is equal to Li di over dt. Now, let's multiply both sides by dt. So we get power times dt is equal to Li di. What is the power times time? That's the energy. This is du. This is du. I put here du. Why? Because the power is energy over time. Okay, or U over time. So we have du is equal to Li di. We're interested in the energy stored in the magnetic field. You see the coil. Here is the coil. Okay. Here is the magnetic field. So inside this solenoid or this coil, there is a magnetic field. So there is energy stored in the magnetic field in the solenoid. The same way as there is energy stored in the electric field in the capacitor. So the solenoid has energy stored in it when there is a current. And we need to find that energy. So what we need to do, we need to integrate to find the energy. On the left side, we get the energy. On the right side, L is fixed. Remember, L depends only on the dimensions of the solenoid. So we get 1/2 Li squared. This is the energy, excuse me. This is the energy stored in the solenoid. Now, if you look at the title here, it says energy stored in a magnetic field and energy density. We need to find the energy density, which means the energy per unit volume. So the energy density, I put here, energy density is equal to U, and I put B here. The reason we have this B is because it's the energy density of the magnetic field. And the reason U is small is because the energy density. It's the energy divided by the volume. So I put here the energy U, which we found, over the volume. Remember, this is not a voltage, it's a volume. What volume? The volume of this solenoid. The volume of the solenoid is equal to the length of the solenoid, here is L, times the cross-section area. So L times A. That's the volume. So I go up here and put UB is equal to the energy. This is the energy that I found. So I put 1/2 Li squared over the volume, L and A. Now, I don't know if you remember, in the previous videos, we found the inductance, L. We found it. Just look back one video or two videos back in time. And you'll find this formula for the inductor. We put N squared L, that's the length of the solenoid, times mu 0 times the area of the solenoid. This is the inductance. We take this, we plug it here. So we get UB is equal, I put here 1/2, I put N squared L mu 0 A I squared over L and A. This is the energy density. But we need to simplify this equation. Look at A, the area, the cross-section area of solenoid. Cancel it. What else can we cancel? Look at L, cancel. So this becomes 1/2 N squared mu squared I squared over, I put here mu squared, and I put, I can do that. I multiply by mu 0 top and the bottom. The reason I multiply by mu 0 top and the bottom, because this is here, what is this? I don't know if you remember. This is, you know, the B field, this is actually B squared. Because the B field of a solenoid, mu 0 Ni, that's the B field inside the solenoid. This one. Field inside solenoid. Okay. Now, the equation becomes this. B squared over 2 mu 0. So, the energy density is equal to B squared over 2 mu 0. This is the energy density. What does that mean? It means inside here, inside the solenoid, the energy per unit volume, you need to take this energy here. If you know the current and you know L, you will find the energy stored in the solenoid. And then you divide by the volume of the solenoid. The volume of the solenoid is like the volume of the cylinder, is the length times the cross-section area, which is here. And that's what gives you the energy density. Okay? So now we found the energy. This is energy stored in solenoid. This is energy stored in the solenoid. And this is the energy density. Energy density. If you remember, for the capacitor, we did this. This is the electric field. Positive, negative, the electric field go this way. There is energy stored in the electric field, and the energy density, UE, is equal to 1/2 epsilon 0 squared. This is the energy stored in the electric field, in the capacitor. This is the energy stored in the magnetic field in the solenoid. Look what's so interesting about this. For the capacitor, the stored energy depends on the field squared. Look, it depends on the field squared. You have this 1/2. You have 1/2. Here you have epsilon 0 is at the top, mu 0 is at the bottom. That's the only difference. But you have 1/2 constant times the field squared. 1/2 constant times the field squared. So there is some parallelism between electricity and magnetism. Okay?